Welcome to this next video. In this next video, we're dealing with examples now of using Newton's method. I hope the two previous videos have set a solid foundation of what we need to do. Just as a reminder here, you've got a question. You use Newton's method to show that there's a solution within that interval. So remember, Newton's formula is given to us, and therefore, whenever you've got this, you've got f of x. What you then want to do is find the derivative of that. So in our case, it's 3x squared minus 1. Very similar. And sometimes now, when you are given the interval, you're not given what your initial value is. So what you then have to do is simply use the midpoint of your interval in order for you to determine what that initial value is. So x0 is going to be -1. So you have to show you're working. So let us set this up. So we know that the first term x1 is going to equals to the initial term that we use. So this will be -1. This will then be minus the fraction. So this becomes x to the 3. So -1 to the 3 minus -1 and then plus 1. Very important for you to do that. And therefore, setting up this becomes -1 squared. And the derivative of that becomes -1. So in every one of this, you then have to sort of show what your solution is at all times. So you'll do an approximation for what you get for x2, and then you'll do an approximation for x3, and then until you go on and see this particular solution converging. So that's what you then need to show every single time. So let's see if this one will actually get to converge. So I will now do the calculator process so that you get a full understanding of what you need to do. All right, so what I will then do to start off with, I know that my initial value is going to be -1. So I'll go -1 on my calculator and press that as my particular answer. And then what I'll do the iterative process now. So the iterative process starts with the bracket. Ans, remember, it does recall my answer is -1. Minus and I now put in my solution. So this becomes ans to the power 3. I'm trying to be a little bit quicker with this. Minus and bracket ans again, and then plus 1. And then in our derivative, this becomes 3x ans squared. And then I'll go -1 from there, because that's what that is. So perfect. So I do get to that. My second solution is -1.5. Please write that down. And then if I press answer again, so that's what I'll do. I get that my next answer is -1,347,826. So please ensure that you are pressing all of those solutions at all times. So that's what my next x2 will be. And then you go on, get your x3, get your x4, get your x5. So have a look at that. And then I press equals to my x6, and you can see that converges. Keep pressing equals to, you will see that it does stick only to that number and nothing changes from there. So therefore, we could say that this converges in 5 steps. And therefore, you then need to go on and show you're working, and that's essentially you done with this particular question. So remember, with each and every single one of this, you'll be working with your calculator next to you. So be sure to ensure that you write your solutions all the time. The first solution was that. The second solution that we got from our calculator was 347826087. The other solution that we got from our calculator after this was -1,325,200,399. And then we got minus 1,324,324,717,957. And remember, this number that we got here was the same going throughout. So without putting the 1 there, these continue to be the number that we converge to. So that's how You then do Newton's method for the questions that you're given. You have to continue pressing equals to and using answer on your calculator to show the solution that you find. In the next video, we'll now do a question that has some trigonometry in it, and let's see how we'll be able to do that. So see you in the next video.